We have studied all the topics, so we're going to have 4 lessons for the review, and you are given the homework already for the it's from math countdown. Okay, I hope you already find the time to finish it. Now remember, before Sunday, if you have any questions, you have trouble to solve, please ask your parents to submit the numbers to me. Okay. What you should do is don't look at the answer key and do all the problems at once. Then check the problems you check all the problems you did. Okay. And if you find that some problems the answer does not match with the answer key, then you redo the problem. Then you still have a few problems left. You cannot figure out the right answer, and then ask your parents to send me the list of the problems. Okay, and I will see that what kind of problems I have troubles most of students. Then I'm going to organize the material, and I'm not just only focus on those problems. Maybe I have to talk about some background material then before I discuss those problems. So that's called review class. Okay. Well, I only got a couple requests from the students on to discuss some problem. This is the first problem from the homework. Okay. This is from a group of 4 boys and 2 girls. 2 students are selected at random. 2 students. What is the probability that the second child selected is a girl? Now, this definitely is it's you select one by one. Okay, right? So select by one. How many students there? Total 6. Okay. So when you trying to find the probability, first of all you get the denominator first, right? So denominator 6 people and put in a row, right? So because you are talking about the order, so 6 people put in a row. Okay. Then how many possible ways to do that, right? So actually there are 6 criteria. 6 criteria meaning possible outcomes without any restriction. Now you want to see the second one is a girl. Okay, how to do that? The second one is girl. Okay, so this must be a girl. Okay, okay. So there are 2 girls only, and you don't know which one is the first, right? The girl or boy. That's okay. You only 2 cases. That's great. So you only have 2 cases. The first one is a boy. Okay. Somebody's calling me this last. Hello. Okay. Yeah, I cannot answer the phone call. Right? Okay, so let me check. So this is the second one G, and then okay. So the first one it could be boy, and it could be so there's 2 cases if you're not certain. Okay. Okay. Right. So there's 2 patterns here, and you can see that, right? There's 2 patterns, and then you decide which one. Then you check. Yeah, you count the number of the possible ways for the first pattern and for the second pattern. Then you solve the problem. Okay? So for the first pattern, either this or that, right? So the first pattern, how many possible outcomes? Okay. So there's a restriction here. The first one must be a boy. So you select the 4 boys. There's 4. Select one boy from the. There's 4 boys that select the one boy first, right? So step 1. That's 4. And then you have to put the girl there, second chair, right? That's 2. That's 2 factorial many. If there's 2 girls and 3, then there'll be, no, that's 2. Okay, 3 is a 3. Okay. Then for the remaining of the student, okay, there are 4 chairs left. 4 chairs left. Okay. 4 chairs left. And 4 students, so just 4 factorial. For the second one, you will get, think about that. Okay, I'll give you a chance. Okay. All right, so you have to put the girl first, right? 2 factorial, and the second one is also good. So it's only 1 student left, then just 2 times 1. Then remaining is just 4 factorial. Okay, so that sometimes you have to divide them into 2 or 3 different patterns. Then for each pattern, you count the number of possible choices. Okay. Now it's guaranteed, right? The second one is girl in this case. Okay, but the first one could be a boy, could be a girl. Okay, so let's simplify this, and then 6 factorial will be 6 times 5 times 4 factorial. So 4 factorial canceled out. Then you get 8 plus 2, right? And here 30. So it's 10 over 30. That's 1/3, not 1/6. Okay. So this is a this is the idea. Sorry, I was a little bit bothered by a student who was just calling me, cannot get online. Hey. So this is about probability. We will still come back to do some probability problems, but not right now. And we finish the probability problems. Okay. Our next problem is about, I'm going to start, review the material. So I will, I think today I'm going to focus on the numbers. Before we do that, let me finish one problem from the homework. Okay. This is about from the extra homework. Okay. This is about a line passes through the 2.05 and -50. Okay. Now, which quadrant is missing? Does not go through, right? So for this one, when you draw the picture, you have to plot the point from 0 to 5. This is 0 and 5. And this is going to be -5 and 0. So when you draw the line, clearly the fourth quadrant, it does not go through. Okay. So this one, okay, the line misses a quadrant. Okay. Now what I want to do is, can we determine the equation for the line? Okay. I already answered the question from problem. So the question is how to determine, okay. Find an equation for the line. I think that was a chapter before we studied and we covered. Okay. Find the equation for the line. Okay. Well, to find the equation for the line, you need a slope. You need the point, 1 point. Okay. So remember, the slope is going to be the difference of the y coordinates and x coordinate. Okay, that actually the ratio this side and that side. It's very clear for in this case. So y coordinate is y minus 0, right? And the difference in the x coordinate, the difference is 0 minus -5. So the answer is 5/5, which is 1. Okay, that's the slope. Now, there's also a formula for the equation. So y minus any of the number is going to be this. Okay, equals the slope times x minus 1. So y1 can be any of the number, right? You can use the point on the left and the 1 times x minus -5. So you get x plus 5. So that is the equation. Y equals x plus 5 is the equation for the line. Okay. Now for the line, that's a very important property is, okay, every triangle you draw like that, they're all similar. Okay, so that those two triangles similar, doesn't matter where those 2 points are located. So if this side are called delta y, this side delta x, then the ratio will be a number independent choice choice of the independent location of the points you choose on the line. So if this was y prime, that x prime, then they are always equal. Okay, because why? Because these two right triangles are similar. So they're always equal. This ratio is called the slope. Okay, is called the slope, because there is only one slope for each line. Okay, that's the meaning of the slope. Okay, yeah, that's the meaning of the slope. So this is a quick review about the coordinate geometry. Okay, now the problems on the math content dump. Those are problems are in general it's not difficult. They're not very deep. You have to use deep ideas. They're usually maximum 2-step problems. Right? And in the real context, a student's only given 45 seconds to get answers. Okay, to give answers. Okay, so you have to do very fast. So then but that tests your knowledge. It covers all the materials. Okay. All right, now, so I'm going to talk about other problems here. Discuss some other problems. Okay, so we're going to focus on the number series problems. Okay, my first question is, what is the sum of the reciprocals all whole numbers divisor of 6? Okay, this is a question. Make sure you understand the divisor of some number. Okay, what is divisor? Divisor is a number you can divide 6. You get an integer. Okay, if 6 is divisible by some number, but that number, positive number, is called a divisor. Right? So when you look at 6, right? 6 could be 1 times 6, could be 2 times 3. Okay. So divisors are 1, 2, 3, 6. Okay. So then then you have to have the 1 plus 1, 1 over 1 plus 1 over 2 plus 1 over 3 and 1 over 6. It will be surprised that this is always equal to 1. Okay. So that's why it's 1 plus 1, that's going to be 2. Okay. So just, yeah. So talking about divisor, uh, divisor could be 1, could be the whole number. Okay. It could be the original number. Now, if I give you question, if I give you sometimes called a factor, okay, a factor of 6. Okay. So my question is, how many factors of, okay, how many factors of 28 has? I hope you remember how to do it. How many factors 28 has? Does yeah, how many factors does 28 have? Okay, we can change the word like that. Okay, so to do that, right, 28 can be factored, right? It's a 2 squared times 7, okay? So a fact must be in the form, a fact must be in the form 2 to the p, 7 to the q, okay? But p can be 0 and 1, but q, 0, 1, and 2, but q can be 0 and 1. So this problem is equivalent to count how many, it's equivalent to count the number of the pairs of such integers. And you have a 3 choices for p, 2 choices for the q. Therefore, okay, total there are 3 times 2, which is 6 pairs of numbers. Okay, those are numbers from the given domain. Okay, so that's total 6, yeah, factors. Okay, this is how do we count the factors. So I'm glad that you know this. Okay. So my next problem is the next problem is a little bit difficult. The sum of 2 whole numbers is 20, and the positive difference is 6. What is the product? What is the product of those 2 numbers? Okay. So how do you solve this type of problems? Well, you write down the given information. So you have 2 numbers. You have to name them. Okay. So first number is called n. Second number is called n. Okay. So now the sum of those 2 numbers is going to be 20. So n plus m is going to be 20. Difference of those 2 numbers is going to be 6. Okay. So you get 2 linear equations. You want to find out, yeah, when you do the problem, you have to make clearly what you're doing here. So you can say that, and we are given this information. We want to find the product. Okay. There are several ways to find the product. One is you solve for n first, then you find the product. Okay. Or you can do it directly. What I'm going to show you 2 different ways. Okay. So you add them together, equation 1, equation 2, you get 2n equals 26, so n equals 13. Then n equals 13, you can use the first equation, m is equal to 20 minus 13, which is 7. Then n times m is 13 times 7, which is 91. Okay, 91 is not a prime number, right? Remember that. Sometimes you confuse. 91 is not a prime number. Okay. All right. So there is another way I want to talk about. It's also important, and sometimes it's good, we want to get. Okay. So x plus y squared is going to be x squared plus y squared and plus 2x times y. That's equation 1. You can also change the sign for y. So you get x squared plus y squared minus 2xy, equation 2. Okay. Then you will see that equation 1 minus equation 2 you will get x plus y squared minus x minus y squared. You get 4xy. So 4xy is going to be x plus y squared minus x minus y squared divided by 4. Xy, yeah. Why we need something like that? Because someday if you write a small program, you want to, if you're given the sum and difference, can you quickly get the product? You cannot write a very long program, ask computer to do step-by-step computation, solving the linear equations. Maybe just the square of the sum minus square of the difference divided by 4, you always get answers. Okay, so in our case, the square of sum is going to be 20, and then square, and then 6 squared divided by 4. And then you can quickly get the answers. Now, I don't want to multiply them out. What I'm going to do is I use 2, 10 square square minus 2 square, 3 square, and 4. Then I can cancel 4. I get 100 minus 9, so it's 91. You see? Okay. Our next problem is a little bit tricky. I will give you half a minute to think about. What is the sum of 5? What is the sum of the consecutive positive integers whose which has the mean of 17? And that's not okay. That's well, that's not difficult. Yeah, let me check. Which have a mean of 17. Yeah. Well, you don't know those as numbers, right? If you can derive a general formula, then be much better. Okay. So you have 5 integers, right? Consecutive integers. Okay. So what I'm going to do is I'm going to derive. Yeah. Well, if you have a consecutive integers 5 and other number, right? So the way you do is you put in the middle. You know, you write in this form. Okay. Then the sum is going to be add all together is just 5n. Okay. And the mean is the number in the middle. So if you know the sum, you know the mean, right? Okay. The mean is, sorry, hold on. Okay. The mean is a 17. Sorry, 5n. This is a sum. Okay. Sum is 5n. Okay. The sum of the 5 consecutive integers, which yeah, no, we don't know that. We know the mean. Okay. We know we have to find the sum. Okay, that's it. So that's why it's 85. Okay. So it goes to this direction. That's the relationship between mean and the sum. Okay. The next one is slightly difficult. The integer a is the sum of the 3 consecutive positive integers and is divisible by 5. What is the least possible value of a? Okay. So a is the sum of 3 consecutive positive integers and divisible by 5. Okay. So what is the least positive value of A. Okay, I can also change the problem as the sum of the product of three consecutive positive integers. Okay, it's also divisible by 5. Okay, so I can after you finish that, you can do that as a problem. Okay, product change product to the sum to the change the sum to the product. Least possible value. What I mean? Okay, the list. Yeah, means the smallest possible value. Okay, satisfying the condition, because there's many numbers you are going to get. Okay, many values you're going to have. You have to pick up the smallest one. Okay. That's right. So you have a three consecutive positive integers. You write it in this way. Okay. And positive means n minus 1 should be greater than 1. Okay. Right? The sum is going to be 3n. That is going to be divisible by 5. So that means the smallest value for n should be equal to 5. Right? Because then this implies n is divisible by 5. So that the smallest value for n should be equal to 5. The smallest. Right? So the answer is a 3n equals 15. Okay. So a is going to be 3n and times n is going to be 15. Okay. Now how about the sum, the product of three consecutive integers? Yeah. Change sum to product. Okay. Okay. What is the smallest value of a? The list of values, list of possible value. Yeah, we use a list, not small. We use a list. Yeah, list. Positive value of a. Okay. Good. You're giving me answers, and everybody is doing well, and do not make any nonsense comments in the chat window. Great. Just give me one answer. It's enough. Okay. So I got 60. Okay. Let's do the problem. Okay. The product. Okay. So how do you view the product? Okay. Well, n minus 1 n, right? I think, okay, you want to, it's divisible by 5. So now you can do the problem directly. But what I want to tell you that the product is always divisible by 6. So there's a factor of 6 there. Okay, but it's also, yeah, but it's not, it's also divisible by 5. Then a number divided by 6 divided by 5, at least you have 30, but not sure you can get 30. Okay, so in order to make sure the product is divisible by 5, you have to one of the number should be 5, right? So I think it begins with 5 and 4 and 3. Yeah, you have to have a number as a factor of 5. Otherwise, you cannot make it divisible. But it guarantee always divided by 6. Okay, so the answer is 60. Yeah, it must contain a factor 5. Okay, good job. All right, now our next problem is how many integers between 2 and 1004, which are multiple of 5. All right. Now, I know you get answers, right? Yeah. So how do we do that? A number is multiple of 5 can be written in the form 5k. Okay. This is between 2 and 1004. We just want to see how many possible values of k can have. The k is going to be integer, right? So you set up the C encode, you then divide both sides by 5. Okay. So the left hand side is 2 over 5. The right hand side is 1004 divided by 5. So we're going to estimate this number is 208. That number is, I don't care. It's a small number. Okay, 0.4. Okay, an integer between 0.4 and 200.8. So the values for the integer could be 1, 2, 3, all the way to 200. So my answer is 200. Okay, that's 200 integer. So actually, yeah, if you ask it to find, yeah, I'm going to introduce a notation. Notation, right? Notation. N is integer, okay? Okay. And not okay. So this is notation. So for any real number x, this notation is called the integer part, okay, of x. So x, for example, 2.4, this give me 2, okay? Yeah, 2.9, that's gonna be 2 still. So that's the same number, okay? Integer, it's the integer part. So my conclusion is, hey, if you want to count the number of possible, yeah, the question is like that: how many positive integers, okay, less than or equal to n, and also divisible by p. To solve this problem, the answer is just n over p and the integer part. And know how to do that. Okay, p times k greater than equal to 1, less than equal to n. So if you then you will get, okay, 1 over p is always less than 1. Okay, so but n over p could be it's not necessary to be integer, because the largest possible value for the k is, you know, is going to be the integer part of n. So my answer is, the answer is this.
Okay, we have to use the integer part of n over p to give the answer. Okay. And how do we get this formula? Just because, yeah, we try to determine the range for the k. Okay, trying to determine the range for the k. Okay. What do you say? You don't get it? Why it's not 99? 199? Okay, let's go back. 100. You see, let's go back, right? You want to find the integers which are multiple 5. So the integer must be expressed as 5 times some integer. And this is between 2 and the 1004. So you solve this inequality. Then you find out k is between 0.4 and 200.8. Okay. And then you know, k could be 1, 2, 3, 4 all the way to 100. Yeah? Yes. So there are so many choices for the k, 200 choices. That's why you get 200. And for every choice of k, you get a multiple 5 between 2 and 1004. Okay. Oh, you don't get p and n, and that's more abstract way to do. Same idea. N could be 1000, 1004, and the p is 5. You think about that, right? If n is 1000, you know, if p is 5, n equals 1004. It's the same idea. You know, you want to divide by p, so that integer can be written in the form p times some k. But that must be between 1 and n because of positive integer, right? And so you solve this inequality, k is between 1 over p less than and n over p, okay, including, right, n over p, okay? So k is integer, but n over p is not necessary to be integer, okay? But this number is always smaller than 1, so k starts from 1 can be. However, n over p is not an integer, but I'm going to choose the integer part. In our example, n over p is going to be 200.8. So the integer part is 200. So that's why k can be 1 to all the way to the integer part of n over k. Okay. Yeah, then, you know, I'm trying to derive the general formula. Yeah. Then you get the theorem. Okay. But yeah, you know, sometimes from a special example, you can summarize it and get the general formula. Okay. So okay, we know that a number is divisible by how many of you still remember how to prove it? Okay, a number is divisible by 11 if and only if the alternate the alternating sum of the digits is divisible by 11. Okay. All right. A number is divisible by 11, and if only if the alternating sum means you change the sign when you add them together. Okay? For example, you know, for example, 6. Let me check. I'll give an example. Okay. Let me give an example. Now, yeah, 6, 8, 3, 4, 5. Okay, let's take a look at this number. Now, is this number divisible by 11? Now, how do you do that? Of course, if you do it by yourself and by manually, just divide by 11. One, it's possible to make a mistake. Second, takes much longer time, right? All you have to do is check the alternative sum. You begin with 3 minus 4 plus 5 minus 6 plus 8. Okay? Then you can do pair by pair, right? 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 So you will get -1, -5, okay? And a -1, and plus 8. So that is going to be 6. Okay. That is going to be 6. So is this going to be divided by 11? No. Okay, so this number is not divisible by 11. Okay. But if I change to, so we are going to, okay, then we're going to do the following problem. I will explain to you why alternate sum of the digits is divisible by 11, okay? So question, okay. If 3, 4, 5, and 8, let's consider this 5-digit integer, okay, is if this integer is divisible by 11, what is n? Okay, n is a digit, okay? Well, actually, we're solving the inverse problem here, okay? We're not given the digit, right? We're not given, the integer and check whether it's divisible by 11 or not. We don't know, we're going to determine, right? I put a 6 there, it's not divisible by 11, okay? So we try, okay? So alternate sum, 3 minus 4 plus 5 minus n plus 8. This is going to be divisible by 11, okay? So let's look at, it is going to be -1, okay? And that's 12 minus n. So what is the possible value for n? Okay? N could be 0, 1, 2, all the way to 9. So this is a divisible by 11. If n only if n must be equal 1. So now you get only one such number divisible by 11, okay? Because 12 minus 1 is going to be 11, okay? Actually, 12 minus 1, the greatest possible value for this is going to be 12. The smallest possible value for this is going to be when n equals 9, it's a 3. So 12 minus n is between 3 and 11. There's only one integer is divisible by 11, which is 11, right? 12 minus n equals 11, and minus n must be equal to 1. Okay. Now, why a 5-digit number A, B, C, D, E, right, is divisible by 11 if only if the alternating sum is divisible by 11? You can prove that using the following expression: n plus e. Okay. So how do we change them? Okay. We you see, we begin with we keep the last one. Then 10 times d, I don't like it. I have to put 11d, so I have to minus d here. Okay. Then once 100 becomes c times 99, so I plus c here. Otherwise, I cannot get it, right? So this is I can move the e here down there. Okay. Okay. Then I have to a. This is a right. Then I have to subtract 1 minus b, so it's 1001. 1001 is divisible by 11. Okay. then then you have a here n plus 8. Okay. Total you add up will be will be still 10,000, right? So this will be the alternating sum. So in other words, I get 9,999A, 1,001B, and 99C, and 11D. That's it, and plus the alternating sum. Okay, so this is alternating sum of the digits. But the numerator is so the first part is always divisible by 11. Okay, and it's easy to check. So this is divisible by 11. That is the reason. Okay, so if a 5-digit number is divisible by 11, if only if the sum of the alternating sum of the digits is divided by 11. Okay, that is the reason. Okay, so those numbers, plus 1 minus 1. Okay, when then you see that, right? 10 to the nth power. Okay, 10 to the nth power. You can summarize it. 10 to the nth power minus 1 plus 1 is divided by 11. So for what n, you will see that when n equals 1, I have to add, when n is odd, right? This is divisible by 11. Okay, when n is 1, 10 plus 1, right? And this, when n is even, this is divisible by 11. Okay, and can you prove that? Why it's always true? It's not easy to prove. Okay, but that's a fact. Okay, are divisible by 11. Okay, so when n equals 4 square, okay, the second one is a little bit easy to prove. 4 to the 10, 4, 10 to the fourth power, you get 9,999, right? But you can also get 10 square minus 1 square, right? Square, right? Okay, so you will get 10 square minus 1, 10 square plus 1. So you end up with the same, so you get, this is not divisible by 11, okay? When this is divisible by 11, this is divisible by 11, and then you continue, 10 minus 1, 10 plus 1. You see there's a factor of 11 there, okay? 10 squared plus 1 is not divisible by 11, okay? And maybe you can find a way to prove this theorem, okay? Yes. Okay. Only when this term is true, then you can show that in general, any integers divided by 11 if only for the ordinate sum divided by 11. Okay. Our next problem is we consider the number 10 factorial, okay, ends with how many zeros if expanded, okay? N factorial by definition is 1 times 2 times 3 all the way to n, right? So please work out this problem. So many students says 2 zeros. Okay. Well, you have 10 factorial, right? It's going to be 1 times 2 times 3 times, and there's 5, 10. So how do we get 0? When we get 0 is only when 5 meets 2, you get 0, right? 10. This is a key part. Okay. Then you look for the factor of 5. There's only one here, and there's one is here. Right. So there's only 2 5s there, 2 factor of 5. If you want to factorize it, okay, so you get 5 squared times 2 some power, right? So as long as there are more than 2 factors of 2 there, then you always get a 10, right? I think the plenty of 2 there. 4, is only 2 squared. That's the reason you get, yeah, that's the reason you get exactly 2 zeros, okay? Because they only have a factor of 2. Okay, does not mean there is a factor of 5, you always get 0. Okay, 5 times 7 is not going to give you any zeros. Only when 5 meets 2, then you get 0. Okay, then you get 0. Now, yeah, but if I change the problems, the number, the number of 100 factorial and was how many zeros? That could be more challenging, honestly, because you needed to count the numbers of factors of 5 there. Are you able to count the numbers of factors? Okay. Yeah. Because there are 25 is going to be 5 squared. Remember that. Okay. And the 100 is going to be also, 5 squared times 4. Okay. So those special numbers containing 2 factors. Right. So how do we find it? First of all, you just step 1. Count those divisible by 5. Okay. So if you count those divided by 5, the total number is 100 divided by 5, which is already 20. Okay, there are 20 integers divided by 5. Okay, nice. Yeah, there are 20 already. And then there are some factors, there are some integers contains 5 squared. Then you also have to pick up those 5s, right? So step 2, you have to count those divisible by 5 squared. Okay, so 100 divided by 5 squared is going to be 4. Okay, and 5 cube, no, that's no 5 cube. 5 cube is going to be 125, is greater than 100, so don't worry about that. Okay, we stop here. The total is going to be 20 plus 4 at 24. So there will be 24 zeros. There's lots of zeros you can create. Okay. Yeah. Because if you just look at the 100 divided by 5, how many integers divided by 5? You have a 20. So same idea, right? But then you pick up all those integers divided by 5. But there are some special integers divided by 5 squared. You have to pick up another 5 there because you only pick up 1. There's 1 5 left, right? So that's why you have to look at how many, look for how many, yeah, look for those integers divided by 5 square. So then you get second round to, to pick up them. So in total, you're going to get 24, okay? And my next question is, what is greatest possible sum of one digit number, okay, and the reciprocal or the negative, okay, negative of the if of its reciprocal. Let's understand what does this mean. You're going to find the sum of one digit integer, and the reciprocal, but negative reciprocal is actually the difference, okay, not the sum. There's a difference. So what is the greatest possible value you can get? And the integer is 1, 2, 3, all the 9. Okay, digits. The digits takes the following values: 1, 2, 3, 4, all the 9, right? Okay. Okay. Well, that's all. I don't know, right? Actually, you should know that in order to make this one as large as possible, you have to choose 9. Okay, because this is a number always smaller than n, but it's always greater than one below that. Okay, so that's the point. So that's why you have to let n to be 9. Okay, then the answer will be 9 minus 109, which is 8, right? And 809. Okay. Yeah, you see that, right? For example, 7 over, right? This is always greater than 6, less than 7. And then just increasing, right? Okay. And then 9 minus 109 is less than 9, greater than 8. So that's why you have to choose that number. All right. Our next question is, we already know this, okay? When a number is divided by 5, the remainder is 3, okay? We know that part. We don't know the number, okay? Can we find out the remainder? Okay, the answer may be no, okay? When twice of this number is divided by 5, is divided by 5. Now, you can choose a special example to solve the problems, but you still, from mathematical point of view, this is still not a complete answer, okay? Because maybe another number which divide by 5 gives you the remainder 3, still, maybe double it. Maybe the remainder is not going to be 1. Okay, so it's better to do it in general way. You're not just specific. If you look at, you can look at specific number. The number could be even could be just 3. How about that, right? If number is 3, then when divided by 5, the remainder is 3. So 2n is going to be 6. So of course, when divided by 6, 6 is the 5 times 1 plus 1. So that is 1 is the remainder. And you find another example, you find it works, but that's not a proof in mathematics. When n equals 8, right? 2n is going to be 16, which is 5 times 3 plus 1, okay? That's just examples, examples. You always see it's 1. Now, if you're doing the experiment in the biology, probably you can publish a paper. You say, oh, based on my observation, this is always true. Okay, and sometimes the experiment cannot be repeated. Then they will suspect you're cheating. Okay, okay. But in mathematics, look at the 2 examples is not enough. Okay, and how do you know in general it's true, right? You have to give a proof. Okay, so not only just give an answer, you have to know how to prove it. Okay, so there's a difference between mathematics and the biology or chemistry. Okay, and so in some literature says mathematics is not a science. Okay, why? Everything's concrete. Is it right or correct? Right? Science is different. Okay, and so a math book, you technically don't need to revise it. If it's really good book, you can use that for 1,000 years, not just 1 year. Okay, 1,000 years. The math book for middle school kids. Okay, I'm pretty sure can be used for many years. But the biology book for high school kids, that book have to be updated every 20 years because the conclusion is wrong. They always do more experiments. Get they get better picture about that. Okay, so let's do this problem. So a number n is divided by 5. The remaining 3 can be written in this form. Okay. All right. Then twice of n is going to be twice of 5p plus 3. That's 10p plus 6. Okay, you got 6. So 6 is going to be 5 plus 1. I can group them together. I get 5, 2p plus 1, and plus 1. So 2m, when divided by 5, you get the new quotient. Okay, the new quotient is 2p plus 1, and the remainder, that's going to be the remainder. Okay, this is going to be the quotient. Okay, so the relationship, the quotient, okay, was originally, sometimes we needed to know that, right? The relationship, okay, if you know the quotient, p is the quotient, then the new quotient will be double the original one plus 1. Okay, even you discover new there when you derive this formula in general, right? This is a p is the quotient of the original, okay? And the quotient for the new number, double n, okay, when divided by 5, is going to be doubled plus 1. Okay. Okay. Okay, got it. So I forgot to ask you to do this problem. Okay, let me try. Okay, let me write down. How many times does the factor 5 occur in the prime factorization of 65 factorial. Okay, so prime factorization is going to be 5 to some point p, right? You can actually you can write in the following way: 2 to the power p, and 3 to the power q, and 5 to the power r. And I think the next one will be 7, and keep it going. Okay, 11 should be there. You know, you have many prime factors here, but I'm just focused on this one. Okay. So my file was disappeared. Just a second. Okay, I'm gonna bring this back. All right, good. Coming back. Sorry for that. Okay. Whoa. My writing. Okay, let me rewrite this again. So I'm going to write in the following: 2p, 3q, 5r, and 7s, and so on. Okay. So I want to find out the r. All right. Let's try. Say question is how many factor 5 there, right? You have to, you know, it's from 1, 2, 3, 4, all the way to 65. So first of all, you need to know, okay, several steps, right? Step 1, you want to find out the number of the integers divisible by, count the integers divisible by 5. Then you just need to look at 65 divided by 5, okay? 65 divided by 5, and so you will get how many of them, right? Right? So you are going to get 13, right? Okay. Then step 2, the same way, you have to count the integers divisible by 5 square. Okay, divided by 5 square. Because those integers contain another factor of 5 there. Okay, so actually there'll be 2. Okay. 65 divided by yeah, actually 2 point something. That was the integer part. So actually 25 and 50. Those are two contains, yeah. Okay. So the answer is 13 plus 2, it's a 15. Yeah, it's a 15. So that 15, this is my the value I equals 15. Okay, those are 15. There are lots of factors there. All right. Let's try next one. Oh, we are done. Okay, we over time, I say. So we stop here. Okay, I haven't. Yeah, we stop here. Okay, it's already over time. Okay, so we haven't. That's why students send me text message.